Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, check out the links in the description below. So now we're just going to get started on our set of questions for today. Okay, so the first question asks, what is the net ionic equation for the reaction between lithium carbonate and calcium chloride? Okay, so when we answer, when we try to find out the net ionic equation, first we want to write out the reaction that occurs. So I'm going to write down my lithium carbonate first, and then it reacts with calcium chloride. And typically what happens is a double displacement reaction. So our lithium will then be bonded with the chlorine. So since lithium has a +1 charge and chlorine has a -1 charge, they will react at a 1-to-1 ratio. And then similarly, calcium has a 2+ charge and carbonate has a -2 charge, so they will also react at a 1-to-1 ratio. I'm also just going to look up the different solubility rules, and we want to do this in order to determine whether or not our calcium carbonate will dissolve in water. Okay, so basically when you have calcium with a carbonate, I don't know if you can read that. So basically compounds that contain carbonate are insoluble except when they're bonded with NH4+ and the alkali metal cations. So since calcium is not an alkali metal, therefore this compound is insoluble. So it won't be aqueous, it will be solid, and it will be the precipitate in the reaction. So after we find out which one of the compounds is insoluble, we want to make sure that this reaction is balanced. So first, let's look at the lithium. You'll notice that on the left side, there are 2 lithiums. So I'm going to put a coefficient of 2 in front of my lithium chloride. Similarly, for the calcium chloride, there's a subscript of 2 where the chlorine is. So this also works to put the 2 in front of the lithium chloride. And then we just want to make sure that the rest is balanced, and it is. So after we write down like the full equation, we are going to write down the ionic equation. And basically what that means is that we are going to separate all of the compounds that are aqueous into their ions. And also we want to make sure that everything is balanced. So we have the lithium carbonate breaking up into 2 lithium ions. A CO3 ion. And then for the calcium chloride, this is going to break up into calcium 2+. plus 2 Cl minus. I'm going to draw the rest on the second line so that there's more room. Okay, so we have 2 lithium plus. Just want to make sure I label these all correctly. Plus 2 chlorine. And the only one that doesn't separate into its ions is the solid calcium carbonate. So I'm just going to keep this as CaCO3S. And now, after we write down the ionic equation, we want to remove any spectator ions. So basically, these are the ions that are the same on both the reactant side and the product side. I'm just going to say ions that can be canceled out. So let's look at our reactant side. There's 2 lithiums and 2 lithiums on the product side. So this is an example of a spectator ion. And then again, we have 2 chlorine ions and then another 2 chlorine ions that will cancel each other out. So finally, after we remove all the spectator ions, we can write down the net ionic equation. So this is what the question is looking for. You can see that it's like a multi-step question. So after we remove the spectator ions, all we are left with is a carbonate and then a calcium. And then we also have our precipitate, calcium carbonate. Okay, so this is our final answer. So let's see what the junior tutor said. To answer this, let us go from the molecular equation to the complete ionic equation, and then lastly to the net ionic equation. The molecular equation and complete ionic equation both show all of the species in the reaction. The difference is that in the complete ionic equation, strong electrolytes are shown as ions. So in our case, a strong electrolyte was like the lithium carbonate and the lithium chloride. If we have a strong acid, it will be shown as H+ and its conjugate base. The molecular and complete ionic equations are shown in equations 1 and 2 respectively. So here they have the same molecular equation that I have in black, and then you'll see that they separate into their ions for equation 2. So we see that the reaction is a double displacement reaction where lithium and calcium displace each other to form 2 salts. The net ionic equation is a way of representing a chemical reaction where only the ions that are directly involved in the reaction are shown. The spectator ions, or ions that do not participate in the reaction, are omitted. And another way of looking at net ionic equations is that the species that appear in both the reactant and product side of the equation cancel each other out. This means that lithium plus and chlorine minus are omitted from the equation, and this is shown in equation 3. This is a very well written answer, so this solution is correct. Okay, so now let's move on to question.